Hello everyone, welcome to today's lesson on special factors. So, now that we've survived the onslaught of the whole ax squared plus b plus c forms, right, let's do a quick little review, but this time we're actually going to teach you some shortcuts. Alright, so let's have a review first though, before our shortcuts lesson. Okay, 10a squared minus a minus 2. Okay, so again, we use whichever method that you like. Once again, I will be using the guess and check crisscross method. That works the best for me, but I'll do decomp as well. Alright, so we can have a and say 10a, 1 and 2. Negative 10 plus 2, that's negative 8, that's not it. How about here? Negative 2 and 10, that's 5. Or that's 8, that's also not it. We can switch it around. Negative 20 plus 1, that's negative 19, that's not it. 20 minus 1 is 19, that's not it. Okay, we'll check different factors. Okay, how about this? Negative 5 and 4, that's it. Write the answer horizontally. Okay, with decomposition, we want a number that multiplies to 10 times negative 2, that's negative 20. So two factors that multiply to negative 20 but add up to negative 1, or that's the one in the middle. So that's negative, what's 5? Yeah, negative 5 and 4. Negative 5 and a plus 4. Right, we just split the negative a here, the middle one, the negative 1 into minus 5 plus 4. Factor out a minus, or factor out a from the first group. Factor out a 2 from the second group. Nice. And then we factor out, whoops. What did I do? Ah. There we go. Factor out a 2a minus 1. Was 5a and 2 plus 2 left over. Okay. Let's check this. b and 5b. Two factors are multiplied to 6c squared, so we can try c and 6c. Oh, actually, we know right away that must be two negative factors, because somehow they have to add up to negative 13 BC. Negative 6 plus negative 5 is negative 11. That's not it. How about c and here instead? It's negative 30 and negative 1. That's negative 31. That's not it. Let's check 2. How about 2 and 3? Oh, look at that. 2 times 5 is negative 10. 1 times negative 3 is negative negative 3. Add them up is negative 13. Okay. And then with decomposition, we multiply those two terms together to get 30 b squared c squared. So two factors of 30 that add up, or that multiply to 30 but add up to negative 13. Right, we get negative 10 and negative 3, right? Negative 3 times negative 10 is 30, positive 30. Added up is negative 13. So I split it up. Take out the 5b from the first clump. And take out a, be careful here, negative 3c, right? Taking out a negative. So you get b and minus 2c. Right, b minus 2c, factor it out. 5b minus 3c. Okay, so yeah, quick little review of last time. If you're still unfamiliar with this, that's okay, right? Just keep practicing. This is not difficult, oh, this is not easy. Okay? But then, there are some polynomials that's actually a lot easier to calculate. We can skip a lot of steps. Alright, so let's expand those first. D plus 2 squared. How do we expand that? Alright, so this is just D plus 2 times D plus 2. Alright, so remember our flying arrows. First term times first term. We FOIL it out. First term, second term. So 2D. Second term, first term. 2 times D is 2D. Second times second is 4. Alright, so quick little expanding review. Once again, squared is just this thing twice. 2e, multiply 2e, 4e squared, 2e times 5, 5 times 2e, 5 times 5. Okay, how about negatives? So this times this. 3f and negative 4. Negative 4, 3f. And then negative 4 times negative 4. Right, so what patterns do we see here when we expand those? And we notice here that this right here is the square of the first term. Right, and in the last term, so this is 3f squared. The last term is just the square of the last term. Oh, I guess second term here in this case, right? Because there's only two terms. Oops. Right, this is just negative 4 squared. So this first term squared is 9f squared. This second term squared, so minus 4. I should extend the line a bit. Right, negative 4 squared is plus 16. And then the last term is just multiplied together, right? You got 3f times negative 4, and then times a 2. That's the middle term here. So this times 2 to get minus 24f. Alright, so we notice the pattern here. Whenever we have just a bracket by itself squared, that will always be the pattern. Okay, so which means that we don't have to do the decomp or any of the methods anymore, because we notice here that we can check, right? 4g squared, the square root of that is 2g. Alright, square root of 4 is 2, square root of g squared is g. And the square root of 5, or square root of 25 is 5. Alright, so again, we're just going backwards here was our pattern. Alright, the square root of that is 5. Actually, let me change the color so it matches. So this is the green. Here's the blue. And then lastly, if we multiply those together, 2g5, and we multiply it by that 2, right, we get 20g. Which means that all we have to do now is to say, okay, so this is just 2g plus 5 squared. Okay, and that's it. Alright, then we're done. This is how we can factor those special polynomials. Alright, let's try another one. Square root of 9h squared. Oh, forgot the color again. (3h) square root of 4 is 2. How about the middle guy? Alright, 2 times 3h times 2. Alright, that gets us positive 12h. Right, which means that in this case, our 2 here must be a negative. Right, because the only way to get to negative 12h is if one of those here is negative. Right, because negative 2 squared is still 4, right? So that doesn't change. So what means for this one is 3h minus 2 squared. Alright, so this is like a shortcut of factoring. Whenever we see the first and the third term, those are perfect squares, we can square root them and multiply it by 2 to check if it equals the middle term. If it does, we can skip all the steps and just write it out like this. Okay, so more specifically, this is called a perfect square trinomial. Right, so pretty much saying that this a plus b squared is square root of the first term plus 2 times first and second term, and then square root of the second term. If it's minus, the same idea, square root of first term, and we subtract those two terms, right? 2 times this term, and then plus b squared. Right? So yeah, this is pretty much what we just covered. So again, we can try a few more of those. Okay, square root this to get 6i, square root of that to get 1, just to make sure the middle one works. 6i times 1 times 2. There's a lot of 12s, I just realized. Right, write down the answer, plus 1 squared. Boom, factored. Quick and easy. Okay, doesn't actually matter what orientation it is. Alright, as long as everything's perfect square. Okay, we can check this. Alright, that indeed multiplies to 56. Remember, it is negative 56 we want. So when you write it out, make sure that it's minus. Okay. Okay, and there's another special one. This one's called difference of squares. Right? So it states that if we have two perfect squares subtracting each other, we can take the square root of that and then have it, right? Have it so that it's the square root of those added to each other, multiply those square roots of those numbers, subtract by each other. Okay, and this works because we can think of it as taking a big square, right? That's a length wide. Right, so this is the area that's a squared. And now let's take out a smaller square, that's b squared. Right, so big square has a side length of a, so the area of a big squared is a squared. We take out a small chunk of a square with a length b, so the small chunk taken out is b squared. Okay, so a squared minus b squared is just big square area minus a small square area. Okay, if we take out the b little strip, right, we can split it up into 3 separate portions. Right, so we have now this square right here. The length of this square is a minus b. Right, it's just length of this a minus this little length here. Right, so the length of this is a minus b. Same with this vertical length, right? The total length is a. We take out the little chunk of b here, so the side length here is a minus b. Right, so this is this little blank square here. Next is the strips, right? We know that this strip right here has the same height as this square. Right? Its height here is just again. This big A taking away the small b. Right, so this is how tall this square, that's a minus b. Now the width of this square, right, that one's a bit more obvious. This is just b, that's b wide. Okay, and then we got 2 of those here, right? So this is b tall and a minus b wide. Right, so we can line it up like this. Right, with a rectangle that's a minus b tall and this wide. And of course, this right here is just a minus b plus b plus b. Okay, which is a plus b. Okay, so that's why this works right here. Right, the reason why a squared minus b squared is a plus b times a minus b is we can literally visualize it with area of a square. Okay, end of yapping. Let's actually see it in action. Square root of 25 is 5. Right, again, this only works with perfect squares. So 6k. Which means the answer to this is 5 plus 6k and 5 minus 6k. Look at that. Right, we can factor it super quickly. Right, so again, this only works for two perfect squares subtracting each other. Okay, difference of squares. And of course, we can easily expand them, right? It's number minus a number, number plus a number, right? So we have m squared minus this number squared, which is 16. Right, so remember, when we go backwards, it's number plus number times number minus number. The result is square of the first number minus square of the second number. Okay, so this is just m squared, and this right here is just 4 squared. So once again, this squared is just 25n squared. This is 9 squared, it's 81. Okay, that's pretty much it. Right, so yeah, that's it for today's lesson. This is special factors. Right, quick little shortcuts for expanding and factoring certain polynomials. Right, again, the regular methods of decomposition or guess and check, they still work. Right, it's just when we see a pattern like this, you can skip some steps and recognize that we have special formulas for those. Okay, but that's pretty much it for all the polynomial stuff. I know it's been a lot, but we are free from polynomials for now. Okay, but with that being said, good luck practicing.